Hi everyone, I'm Alish Dipani from the team UAI-CNRL. I'll be presenting our approach to the MediaEval 2020 task, emotions and themes in music. This work was done by me, Gaurav, Iyer and Veeky. We are from Upload AI LLC and Cognitive Neuroscience Lab at BetScore. So the task is given an audio sample. We have to predict one or multiple moods or themes. Some examples of these tags are happy, calm, sad, or love. We use the MTG-Jamendo dataset, which provides mil spectrograms of audios with a total of 96 mil bands. These audios range from 30 seconds up to 3900 seconds. And we have a total of around 10,000 training samples as well as 3,800 testing samples. Our approach is that we use the mel spectrograms to input into convolutional neural networks which extract the features. Then we process these features using multiple multi-headed self-attention layers, which detects long-range dependencies. And finally, we have a simple linear layer to predict the tags. We also use several augmentations such as spec augment, which randomly masks out blocks of frequency channels as well as time steps. We also use mixup, which is linearly combining two random samples in feature space as well as in label space. Finally, we apply random cropping and scaling to bring the final shape of the tensor from to 96 cross 4096, which corresponds to approximately 87.4 seconds of audio. We then divide this tensor into 16 segments, each of in which each has the shape 96 cross 256. Our architecture is as follows. For feature extraction, we first have two convolutional layers, which are responsible to bringing the number of channels up to 3. We then use a ResNet34 architecture, which has not been pre-trained. And finally, we use a single convolutional layer to decrease the number of channels. Then we input the feature extracted from all the 16 segments to two multi-head attention layers, of which each has 4 heads. And finally, we have a linear layer and to predict the tags, and we also use dropout to regularize the model. So our results are as follows. We outperform the VGG baseline as well as the popularity baseline in all the macro metrics, but not in some of the micro metrics. Our approach can further be improved using two approaches. First one would be improving the feature extraction. So instead of using mel spectrograms, we can use approaches like LEAF, which uses Gabor filters instead of SCFT on the raw audios. Or we can use pre-trained self-supervised models such as Wave2Vec2 for extracting the features. And for improving the extracted processing of the extracted features, we can use the dual path processing idea, which improves upon the detection of long range dependencies. Thank you.